In Texas, a suburban road collapses without warning.
Man, if it's a sinkhole, how big is it and how much bigger is it going to be?
In the UK, a cutting-edge build goes back to square one.
The ground underneath it had actually started to move. We were absolutely shocked.
One of America's most deadly disasters strikes in Missouri.
And that put my eyes right on the second floor walkway as it began to break apart.
And in Iowa, work on a crucial safety project grinds to a halt.
The number of crashes at this location were more than double the statewide average.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. In the pursuit of audacious builds, engineers take on ever more unique challenges. Any mistake could lead to catastrophe. Like this tragedy in Missouri that left a nation reeling.
I was not ready for what I saw. It looked like a war zone.
Miscalculations combined with a change of plan had devastating consequences.
The Hyatt Skywalk's disaster is one of the great disasters in American engineering history.
Kansas City, Missouri. Once famed for its cattle markets, the city became a major destination for work and play. Michael Mahoney is a local TV reporter.
Kansas City is a place where lots of people from the Midwest either come to work and try to develop careers here, or they come here for visiting because it's one of the nearest big cities.
One big draw has long been music.
In the 20s, during Prohibition, Kansas City was sort of like Las Vegas. Anything goes. We had lots of late after-hours nightclubs, and the sort of jazz that developed here was called the Kansas City Jazz, and it's based off blues, and it's very distinctive.
In the 70s, as Kansas City's popularity boomed, distinctive new architecture began to appear, including a new luxury hotel. When it opened in July 1980, its 45-story tower dominated the skyline.
At the time, the tower was the tallest building in Missouri. It even had a revolving restaurant perched at the top with views across the whole city. But the architectural ambition didn't stop with the exterior.
Attached to the tower was a vast atrium, 15 meters high, designed to draw the crowds.
They wanted some piece of architecture, some piece of that lobby, so that when somebody would walk into it, they would go, goodness! And what they had here were these suspended walkways, 3 of them.
The suspended walkways gave stunning views of the space below, which in music-mad Kansas City doubled as a dance floor.
The concept of floating floorways above the lobby wasn't just truly spectacular, it was a serious engineering challenge too.
Kathy Hagan is a structural engineer.
There were 3 walkways, one at the 4th floor, the 3rd floor, and the 2nd floor, that just connected so people could walk across and get back and forth between those 2 areas. The walkways were hung with rods that were placed at quarter points, and they were about 1 1/4 inch diameter steel rods.
The 3rd floor walkway hung alone, but the 4th and 2nd were suspended together.
The rod was supposed to start at the 4th floor and go down through the 4th floor walkway and then down to the 2nd floor, and it was supposed to be one continuous rod.
The plan was for 6 14-meter-long rods to hang from the ceiling. The top walkway would slide up the rods with steel box beams supporting the deck, all held in place by large steel nuts. The lower walkway would then be lifted onto the same rods and attached the same way.
The fact that these walkways had no support from the ground and seemed to hang in space made the impact even more impressive.
The trailblazing hotel was completed in 1980 and soon became the place to be.
The intent of it was to have people come down on a Friday night and have a couple of drinks after work and enjoy the music and dance. And the word got around that this was kind of a cool thing to be doing in Kansas City, a way to kick off your weekend.
July the 17th, 1981, the hotel's Friday night tea dance was in full swing. Michael was covering the event for local news.
They had a good crowd. They had well over 1,000 people, no doubt about that. There were people up on the walkways looking at the vista down underneath of all the people dancing.
Just after 7 p.m., Michael and his crew were taking a quick break.
What we were doing was changing the batteries of our camera gear so that we could do the interviews. And at that point, I heard this really sharp pop, pop. And it was not a sound that was coming from the band. It was just an alien sound to the environment. And I immediately looked up to where I saw or felt like I heard the source of the sound. And that put my eyes right on the second floor walkway as it began to break apart. And I could see the second floor walkway begin to sag and then break apart a little bit. And at the same time, that part of the collapse also drug the fourth floor walkway down on it, and it slammed into it. They both dropped suddenly to the ground.
The second and fourth floor skyways had completely collapsed.
Two things were really, really memorable. Number one was the dust. The lobby of the hotel just filled with this pretty thick cloud of dust. And then the other thing that was striking was the silence.
Fire department.
Okay, would you please call to the Hyatt Regency? Have you been called yet?
No, what's the problem?
Okay, 3 of our sky bridges have fallen. We have injured people. Can you come right away? We're on the corner of Pershing and McGee.
A police officer at the time, Joe Kern, was one of the first to be called.
I got paged and told me to get to the Hyatt immediately. They had a major disaster. There was officers outside trying to control the traffic, trying to keep people out of there. But I was probably the third or fourth that actually walked into the lobby, and I was not ready for what I saw. It looked like a war zone. It really did. It looked like somebody had just shot a big old bomb in there and just blew the place up.
216 people were injured in the catastrophe. Tragically, 114 lost their lives.
"42 years on Kansas City Police Department. It is the worst disaster that I have ever dealt with. I have never been back in that building.
It's difficult to comprehend the scale of this tragedy. This is the kind of disaster that every engineer dreads.
The Skyway collapse was the worst construction accident in US history.
The Hyatt Regency collapse at the time it occurred was the most devastating loss of life due to an engineering failure on record.
In the aftermath, state and city officials called for a thorough investigation. And the first clue was right above their heads.
The steel hanger rods were still attached to the roof, some with the nuts still in place. So if the supporting rods hadn't failed, the problem had to be with the walkways themselves.
After examining the walkways, investigators found unexpected damage. The box beams were splayed at the ends, where the hanger rods had once been connected.
The box beams were made of two halves known as channels, welded together top and bottom to make a box. But the welds were ripped and the boxes had split open.
Investigators believed the collapse initiated at the connection known as 9UE, which showed both buckling of the beam and torn welds.
So if you're looking like through the end of it, there was like these two channels that were back to back, and the bolt basically went through here and the legs of those channels just bent up. It pulled through that one and then it pulled through this one.
Calculations from the design phase found that these beams could support the walkways, but clearly they weren't up to the job. The question was why?
It seems the calculations were flawed and the connections were weaker than expected, but that wasn't all. Further investigation revealed there had also been a crucial design change made during construction. As a result, each hanger was made from not one, but 2 rods.
So this is a schematic drawing of the change. So this would have been the original rod going through the 4th floor walkway and the 2nd floor walkway. And then each bolt would have basically had that level's weight on it.
In the designs, one 15-meter-long rod supported both decks at each connection. The new layout used 2 rods, one from the roof to the 4th floor, a second from the 4th to the 2nd floor.
When they changed it, they went to 2 rods. So they had the first rod that came down, and then they offset that. And so then this rod, this bolt basically carries the load of this floor, but then this bolt basically carries 2 times the load because it carries this floor and itself. And so that was the initiation point of the failure that evening.
A good analogy is 2 people holding onto a rope. If each only holds their own weight, like the original plan, everything's fine. But if one hangs from the other, like the change, unless the top person is super strong, they'll both fall.
Investigators later discovered, even with the original layout, the walkways were barely strong enough to support their own weight. The switch to 2 rods was catastrophic.
The design change was requested because they would have had to thread the 4th floor on completely onto the rod, and it would have been very time-consuming and difficult to construct. So it was requested so it was easier to construct.
This change to the design probably seemed like a relatively small and practical solution at the time, but the consequences couldn't have been any bigger.
As the connections failed, the girders slipped down over the nuts, rendering them useless, triggering a cascade effect, bringing down both skyways. After the disaster, the whole atrium required major repairs. But in time, the skywalks were replaced, although with lessons learned from the tragedy.
The 2nd and 4th floor walkways were completely redesigned and rebuilt, this time supported by columns from below instead of hanging from the sky.
For the people of Kansas City, the tragic event of 1981 will never be forgotten.
We're at the Skywalk Memorial. This is actually the first time I've been here since the night of the tragedy. On each side of the pillars, there's the names of the people that lost their lives.
It's a true reminder of the responsibility that everyone takes on when it comes to building big structures.
The Hyatt Skywalk's disaster is one of the great disasters in not only Kansas City history, but American engineering history.
Catastrophe can strike long before construction crews leave the site. But some lie lurking, a disaster waiting to happen. Like this tragedy in Texas, which appeared out of nowhere.
If anybody was to fall into this hole, they were going to get sucked underground and they were going to get taken.
An engineering fail with huge consequences.
There was no warning. This road just dropped into the hole.
San Antonio, Texas, a city with a rich past and home to one of the most iconic standoffs in US history. Local radio producer Jan Ross Piedad remembers the Alamo.
The Alamo is a big, big thing, not just for Texans, but now for Americans. For a lot of folks, it's a symbol of freedom and kind of fighting for independence.
But this historic city has its sights set on the future too.
So San Antonio has been up and coming in recent years. We're actually the 2nd fastest growing city in the country and also 7th most populous. San Antonio is a really amazing city.
With population growth like this come engineering challenges. L. David Givler is a civil engineer.
When you consider the history of San Antonio, it was a mission outpost under the Spanish, then it was a cowboy town, and today it's a thriving city. So there's been a lot of growth, and the old infrastructure of the past is just inadequate to support the current demands.
One piece of city infrastructure has been undergoing a massive upgrade: the sewage system.
In this case, there was deteriorating infrastructure, and because of that, a consent decree was issued for San Antonio to repair the sewer system. There were thousands of feet in each phase needed to be repaired, so it was an ongoing multi-year process.
San Antonio has a vast network of buried pipelines for water and sewage. Digging it up piece by piece and replacing it would be a mammoth undertaking.
In 2016, the infrastructure upgrade was going according to plan, but trouble was lurking beneath the streets. December the 5th, heavy rain was rolling through San Antonio. Mark Moody was on duty at the fire department when a call came in.
We were at the station, and it comes in. We look at the computer, and it says there's a sinkhole. Well, that's strange. It's definitely not something we make every day.
Mark sped to the scene.
The weather was nasty. Visibility was tricky. The biggest thought was, man, if it's a sinkhole, how big is it and how much bigger is it going to be?
What the team found was shocking. A massive sinkhole had swallowed the road and was filling with water. When Mark arrived, the area was already being secured.
The police department had shut down all the roads coming in here to about right here.
Mark and the team had no idea how stable the ground was.
I walked up to approach the scene so we could determine how close we could actually get to the scene with the trucks without having any problems. We had a car on that side of the road that was right side up, and then on this side right here in front of me pretty much was a car that appeared to be upside down. All I could see was a single tire.
Darkness and poor visibility had made it impossible for these drivers to spot the sinkhole. Fortunately, 2 people climbed to safety, but rescuers weren't sure if everyone had made it out.
Obviously, something was allowing water to rush into this hole. The water was spinning, and it was sucking down and going out. If anybody was to fall into this hole, they were gonna get sucked underground and they were gonna get taken. Water's kind of a strange thing. It can look not violent, and it can be extremely violent. I think that the water is probably the most dangerous thing we have that we deal with because it is so deceptive. Nobody was going to be able to fight against that power of that water to get out of there.
Overnight, word spread about the sinkhole. The next morning, Jan arrived to cover the story as Mark and the team tried to recover the inverted car.
It was just a cold December morning. We were just waiting on bated breath to see how it would go. It was a somber moment to be witnessing.
We brought our ladder out over the back of our truck. So from there, we sent a couple guys down on rope down to the bottom of the car and assessed it for stability, for ways that we could connect to it. Our guys were able to connect the crane to the car, and then the crane was able to lift the car up and set it down over here on the side of the road.
And I remember the car kind of rise up with all that brown water. Later for us to realize that there was a person in there.
When the car fell and rolled over, its driver hadn't stood a chance. As the city mourned, drivers were fearful of hidden pitfalls under their roads and wanted to know why this one had collapsed. One possibility was the very ground upon which San Antonio sits, as geologist Matt Cannon explains.
If you know much about the geology of San Antonio, you know that we exist in a sea of limestone here. Limestones are very easily dissolved by weakly acidic water, which leads to the formation of karst and sinkholes.
The limestone around San Antonio dissolves very slowly, but it's riddled with caves. And when the roofs get too thin, they collapse without warning, forming sinkholes.
Matt quickly realized there was more to this catastrophe than geology.
As soon as I saw images of the sinkhole itself and the aftermath of it, it was clear that this was a human-induced sinkhole. This was a pipe that broke and suddenly released an enormous volume of water underground. When you suddenly unleash that volume of water, moving at those speeds underground, the rate of dissolution of material is going to be very rapid, especially in unconsolidated sediment like what we had in this particular case.
The problem appeared to stem from a sewage pipe that had been undergoing renovation. L. David Givler was called in to investigate.
Here we have the original 54-inch or 4.5-foot diameter sanitary sewer pipe that was installed in the 1960s. The old pipe was concrete. The new pipe was something called FRP, fiber reinforced polymer. And this is a new junction box 4, which was also installed as part of the Phase 2 work.
The junction box joined the old concrete pipe and the new, much wider reinforced polymer pipe, but the temporary fix was flawed.
Corrugated metal pipe was used for the temporary connection here, but that's not standard. Metal pipe is almost never used in sanitary sewer systems. And the reason is because sewerage has gas dissolved in it called hydrogen sulfide.
When hydrogen sulfide mixes with bacteria from the sewage, it creates sulfuric acid, which is highly corrosive to some metals, and it had been eating away at the corrugated pipe.
Instead of acid dissolving the limestone, in this case, it had dissolved the pipe.
This photo shows the corrosive nature of the environment that was in the pipe and gives some hints as to how it deteriorated. It was an 18-foot pipe, and there were only a few pieces of it left after the acid had done its work.
Delays in the project meant the makeshift pipe was in place for 21 months, slowly being dissolved. But the material wasn't the only problem.
There's another complicating factor here, and that's that this connection at junction box 4 was not a secure connection. There wasn't any structural aspect of this connection that prevented the pipe from sliding down. And then this wasn't watertight, so this was creating a flow path for any leaking water to erode soil out and into the junction box.
The choice of material, combined with a lack of support, meant that this connection was never up to the job.
As the connection failed, sewage began to leak from the pipe, silently washing away the ground beneath the road with tragic consequences. The solution here was straightforward. The temporary connection was replaced with a permanent section and the road rebuilt above it. But it was an important reminder of how vital functioning infrastructure is.
When you just consider how people think about sewer lines, I mean, they're boring, insignificant, and here's an example of what can happen when the chemistry and the physics of the situation take over and disaster results.
That's the problem with buried infrastructure. It's impossible to monitor every last piece, and if something goes wrong, you might not know it until it's too late.
This tragic case caught the city's attention and prompted significant changes.
Billions of dollars were allocated towards having better sewage infrastructure, but it's also possibly a cautionary tale of making sure that when those plans are set, that the job is done right.
In engineering, construction success always begins with solid foundations. But sometimes the unexpected can sink even the best laid plans. Like this disaster in the UK, a building demolished just weeks before its completion.
This is the first time that I've ever come across a story like this.
An engineering fail that came to light at the 11th hour.
I was shocked. I thought, how could they mess this up that badly?
and a trailblazing build goes back to the drawing board.
Sometimes there's just no option but to start over.
The ancient city of Sheffield, England, for centuries home to a world-famous cutlery industry and the birthplace of stainless steel. Alana Roberts is a local journalist.
Sheffield is actually very well known for its steel industry and its steel heritage. A lot of the buildings around Sheffield are actually quite old.
As well as forging steel, Sheffield has a reputation for forging great minds, with a university population of around 60,000.
Sheffield is a very kind of student-focused town. The University of Sheffield campus really kind of stretches across the city. It's very well known. Everything kind of centres around the universities.
In 2018, the University of Sheffield unveiled plans for a new state-of-the-art building, designed with sustainability at its core. Jake Loader was an undergrad at the time.
When the plans for this building were announced, there was so much excitement from the students. It was going to be this massive, sustainable, really advanced technological building. We just couldn't wait to get in there and start to use it.
The structure's curved steel frame echoed the city's industrial past, but its staggered glass facade was more than cosmetic, designed to allow light in while keeping heat out, boosting the building's eco-credentials.
The building that we're using at the moment, it's dark, it's dingy, it's depressing. This brand new building is going to be incredible.
Construction on the £65 million project began in May 2019 on the site of an old sports field. Like any structure, it would rely on solid foundations with deep footings known as piles. Geotechnical engineer Jeffrey Pereira specialises in pile foundations.
Piling is done mainly to support and give the stability to the building. Just imagine that you're trying to build a house on a bowl of jelly. If you put the house on the bowl, it will just sink through the jelly. So what piling does is holds the house up such that it doesn't sink down.
With many projects, piles are driven down into the bedrock, creating a solid base to build on. But this wasn't a normal construction site. The groundbreaking build was above a former reservoir.
The reservoir had been there since the 18th century, but in the 1950s, it wasn't needed anymore, and the hole was filled with rubble. The messy ground was a real challenge for engineers.
The entire footprint of the building was above the old Godfrey Reservoir. The rubble fill, said to be from buildings bombed in the World War II Blitz, was less than ideal for sinking pile foundations into. Despite the complexities, the build was scheduled to take about 2 years. Due for completion in the summer of 2021, just in time for the new academic year.
We walk past it every day. Each week there was a new development, and it's ridiculously exciting. First of all, you've got the foundations, then the next week you can walk past it, you can see the concrete, and it got to the point where you could really see the building starting to take shape. We were all absolutely buzzing to get in it.
This was to be a world-class construction for a world-class university. May 2020, and work on the new building was making good progress. But just as the main frame was nearing completion, the build hit the brakes.
I woke up to a text from my mate in the morning. He said, "Have you seen the news that half the building was going to be knocked down? The ground underneath it had actually started to move." We were absolutely shocked.
Worse was to follow. In August 2020, with partial demolition underway, contractors announced that the entire building would need to be torn down. For local journalist Alana Roberts, this was breaking news.
The university and the contractor actually announced that there would be a full demolition of the site. It really shocked me that something like this could go on. This is the first time that I've ever come across a story like this.
It's normal for construction projects to go over schedule, over budget, or both, but to have to knock something down and start over, something must have gone seriously wrong.
I thought, how could they mess this up that badly? How can you make a mistake that big?
What had gone so wrong with this state-of-the-art structure? The developers discovered the problem lay with the pile foundations. Geotechnical engineer Jeffrey Pereira explains.
Piling is like our legs for the building. If you have very strong and steady legs, then you hold the building out really straight and well. But if you have wobbly legs, then the building will tend to sway and eventually crack. So the better the legs you have, the better the support is for the building. It is really important to get your piling right.
Here, it seems the problem stemmed from the very early stages of preparation.
Like any construction project, ground investigation was carried out to make sure the project could go ahead, but given that they were building above a rubble-filled reservoir, it was particularly important.
To get a really accurate picture of the ground, engineers drill a network of boreholes so they can see for themselves what's underground.
The ground inspection was thorough, but as the structure was nearing completion, unexpected levels of subsidence were recorded.
We designed the piles to settle to within an allowable limit. We know that the building can withstand certain movement in the pile and yet still be fit for use.
The initial plans allowed for up to 25 millimeters of movement, but here the settling exceeded that in multiple places. For a building this size, it's unacceptable.
Every building will settle to some degree, but here it was a lot more than expected, and there was no way to be sure it wouldn't get worse with time.
The exact reasons haven't been revealed, but it's possible the ground investigations didn't paint an accurate picture of the rubble beneath.
In this case, some boreholes might have been drilled in places that didn't give a true reflection of the ground around them.
Accurate data about the depth of the bedrock would be crucial.
What potentially may have happened is that because there was no data available between these boreholes, you could have got a very deep cavern within the former reservoir. And imagine you piling to this level, you've got a pile that is just hanging in poor soil. When these piles are loaded, it's just going to go down.
If placed too shallow in poor soil or over an undetected void, the piles simply wouldn't do their job.
Because the piles were not deep enough and were not built into the competent soil, they kind of gave way and caused excessive settlement, and the building was deemed to be not fit for purpose.
With lessons learned and more reliable foundations laid, by 2021 building was once again underway. But starting over had pushed completion back by more than a year.
The residents nearby were actually calling the contractors the neighbours from hell because of the noise, because of the dust. They just had enough.
Now when I walk past the building site, that excitement's gone. I'm never going to get to use it. The excitement's been replaced by loud noises and rubble and dust. And it's frustrating. It's just a constant reminder that we're never going to get to step foot inside this building.
Ultimately, this is a reminder that every project comes with its own unique problems. You just have to hope you don't miss any of them.
With big infrastructure, every calculation is vital. Get one wrong and the whole thing can grind to a halt. Like this highway holdup in Iowa on a major safety project.
The number of crashes at this location were more than double the statewide average.
Mistakes that stopped construction in its tracks.
You're going to have, jackhammer off the top of the concrete pier.
This fail had drivers asking what had happened. America. Few things have shaped the nation as much as the automobile. It's now home to more than 250 million vehicles. Todd Wessel is a travel journalist.
Americans love their cars and they love the open roads. They love the wide open spaces. They love to go out west and go into the mountains, and it's all part of being an American.
At more than 6 million kilometers, America has the biggest and longest road network on the planet. It's also home to some of the world's longest highways.
US Route 30 is the third longest highway in the country and stretches nearly 5,000 kilometers from Oregon to New Jersey.
It was the first transcontinental road in the history of the United States. It was built in 1913, right at a time when cars were starting to become the preferred method of travel. Its importance is immeasurable for our country.
Like every major road on Earth, keeping Highway 30 maintained has been a constant battle.
US 30 from Marshalltown to Ogden is a 55-mile section of primary highway in Iowa that needs to be modernized.
Highway 30 originally passed through every small town along the route. In the 50s, as traffic volume increased, one major bottleneck was the town of Ames, Iowa. Luckily, road planners had come up with ways to ease the flow.
One key improvement in the late 1950s was the building of roads that went around towns instead of through, known as a bypass. Bigger roads, less traffic, faster journeys.
Faster flowing traffic needed faster flowing intersections with no traffic lights or hard turns to stop vehicles in their tracks. Like this cloverleaf interchange at Ames, connecting Highway 30 with the key north-south artery, I-35. Tony Gustafson is an engineer with the Iowa Department of Transportation.
A key thoroughfare for the whole country, Interstate 35, and especially in Iowa, you know, it carries a tremendous amount of traffic to keep Iowa, the goods and people flowing across the state.
Highway 30 and the I-35 are major transcontinental transportation links, with more than 40,000 vehicles using the Ames intersection every day. This is one seriously busy junction.
But 5 decades after construction, the old cloverleaf design was struggling to cope with demand and had become a major accident hotspot.
You get that many vehicles mixing together at the same time, it's just the odds are more probable that you're going to have a type of collision between vehicles.
When built, the cloverleaf smoothed the transition between highways, but to safely make the 270-degree loop, drivers had to slow down to about 40 kilometers an hour. With more and faster traffic, the clash between high and low-speed vehicles was a major concern.
The number of crashes at this location, just in the northbound direction, was approximately 25 to 30 crashes a year, which is more than double the statewide average.
Engineers desperately needed a safer way to handle traffic. In 2016, work began outside Ames on this new exit ramp and overpass, carrying vehicles from the northbound I-35 to westbound Highway 30.
We're looking south right now at the flyover, the south end of the flyover. Northbound I-35 traffic is going underneath the flyover. So again, you can see the bridge span.
The flyover consists of 8 two-lane bridge spans supported by 6 piers, creating a long, smooth curve from I-35 up and over the main roadways, allowing vehicles to switch freeways without significantly slowing down.
It's a beautiful bridge. We're proud of it. You can see they have some aesthetic features on the piers. A weathered steel beam kind of fits into the natural environment here in Iowa.
This $23 million safety solution was initially scheduled to open to traffic in 2018, but months before its completion, construction had to be put on hold. The problem lay within the 6 concrete piers that were designed to support the roadway.
When the piers were completed, 2 problems were spotted. First, the anchor bolts for the bridge decks were in the wrong position. Secondly, all 6 piers were too high. There's no way the decks would fit.
One of Iowa's largest and most expensive construction projects, designed to make a safer intersection, had ground to a halt. Officials said the issue most likely stemmed from the initial survey. Like many projects, it relied on Global Positioning System, or GPS.
Global positioning systems have been around for years. Invented by the US military, today GPS is everywhere. Our vehicles, our phones, and even on a watch.
Assistant Professor of Engineering Roy Sturgill explains, with the help of his student Jay.
And the first thing that Jay's going to do is set up the equipment for the base station over top of a known point.
At any given moment, the base station can detect its position in 3 dimensions, relative to satellites orbiting the Earth.
We have 2 GPS antennas. One we're going to use as the base station. The second we're going to use as the rover. This antenna will not only communicate with the GPS satellites, but will also be communicating with the base station. Everything's controlled by our data collector here. Once the system's calibrated, from there we can start collecting data.
The fixed base station plots the exact location of the rover, allowing engineers to accurately plan out any new structure. With the exit ramp, getting the shape right, both in gradient and curvature, was vital to safe, smooth operations.
The initial layout tells the rest of your contracting crew where bits and pieces and parts of the project are going to go in. So it's critically important that your survey work is as accurate as it can possibly be, because it sets the stage for the rest of your project.
Today, GPS is an essential tool for all big engineering projects. But like any technology, it's how it's used that matters.
So GPS surveying is something that looks really easy, and the equipment makes it feel very easy, but there's a lot of opportunities for things to go wrong.
It seems something did indeed go wrong when plotting out the new Ames exit ramp, that resulted in the piers being too high.
With the pier heights being incorrect, the impacts that would have is that the vertical curvature, the horizontal curvature, and even the super elevation of that flyover would have been impacted by those varying heights.
This roadway was designed to make travel safer, but there was no way construction could continue.
Mistakes happen on every project. There's no perfect project. It's all in determining where those mistakes are and trying to figure out how to fix them.
Given the junction was an accident hotspot, engineers worked tirelessly to devise a solution to both problems.
Once you're dealing with in-place and cured concrete, you're left with no choice other than to chip off the tops of the pier to the point where you reach a sound point and then can reconstruct it without damaging anything else. So that is a very tedious process and does take time to do that appropriately.
The answer lay in brute force.
You're going to have, hydraulic or pneumatic hammers to come in there and jackhammer off the top of the concrete pier.
The solution might not have been elegant, but it was very simple.
When the piers were down to height, the concrete tops were re-poured, this time with the anchor bolts in the correct positions. The new ramp finally opened in 2019 with great success. Vehicle collisions at the junction have dropped significantly.
A bridge is going to be here for 100 years, we hope, and we're proud of the little extra time it took to build it. The citizens of Iowa and the DOT are very proud of.
And engineering lessons were learned along the way.
So in terms of lessons learned from this project, I think it is a good lesson to understand, the use of GPS technology, the use of importance of surveying.
Even with the most sophisticated technology around, mistakes still happen. Thankfully, the errors were found before it was too late, and traffic is flowing safely between the highways.
With proper foresight and modern engineering techniques, highways of today and tomorrow can be our best investment